All right, in this video, we're going to look at problem number 4. Sorry, look at my pen. All right, I'm going to do this on lined paper so I have a little bit more space. All right, it says a hot air balloon is ascending at a rate of 14 meters per second. So I'm going to draw my hot air balloon over here. So here's my hot air balloon, and it is going upward with a velocity of 14 meters per second. And the hot air balloon is 61 meters above the ground. So my picture's maybe not to scale, but we will call this distance here 61 meters. All right, when a package is dropped over the side, sketch a picture of the path of the package upon release. So we're going to stick our hand out of the hot air balloon and we're going to drop a package. So this is going to be the package. I'll put it right there. So most people think that if you were in a hot air balloon and you reach your hand over the side and you drop something, that it's immediately going to fall down. Well, it would immediately fall down if that hot air balloon was just hovering there, just kind of like sitting in still air. But this hot air balloon was going upward with a velocity of 14. So when you let go of that package, Newton's first law says an object is going to keep doing whatever it was doing. So as soon as I let go of this package, it is not going to fall straight down. It's actually going to start to go up with an initial velocity of 14. So it's going to go up like a little bit, and then when it runs out of velocity, it's going to start to fall down. Technically, it would be going straight up and falling straight back down on its path, but I just kind of spread it out a little bit so that we would have a little bit of room to write. All right, so we know that the package would have an initial velocity of 14 meters per second. I'm not going to write the units due to space. And it's going to keep on going upward until it runs out of velocity. So the final velocity at the top of this path is going to be 0. It's going to get slowed down by gravity. So that is negative 9.8. And I would like to know how long it's going to take to get to the top of the path. So you can see that we could use our first acceleration equation. Let me move this up. We could go VF equals VI plus AT. That would be 0, 14 minus 9.8 times T. And so T will turn out to be 14 divided by 9.8. I'll do that real quick. 14 divided by 9.8. I get 1.43 seconds. So that's how long it's going to go up. And then after it gets to the top, then it's going to fall down. So to find out the time that it's in the air, I'm going to have to find the time to go down also. But I can't find the time to go down until I know how high up it went. So really right now, I'm kind of looking just for this distance here. So I'm just going to add a distance to my list. I need to know how high up it went. So I think we could use the third equation to find how high up. That's going to be 0, 14 squared plus 2, negative 9.8 times D. So D is going to turn out to be 14 squared divided by 2 divided by 9.8. You can do your own algebra. And I get 10 meters. So it's going to go up for 10 meters. So the balloon, though, was 61 meters above the ground. So we have 61 meters here plus another 10. So I now am going to be up here at a distance of 71 meters when it starts to fall down. So let's talk about the falling down. On the falling down side, it's going to start with an initial velocity of 0, and it's going to fall for these 71 meters. It's going to pick up speed due to the acceleration. It's going to take some time to fall, and it's going to hit the ground with a final velocity of we don't know what. So we don't know the time and we don't know the final velocity. Let's work on the time. How about this equation? The second one, BIT plus 1/2 AT squared. So the distance is 71. The initial velocity is 0 plus 1/2, 9.8 T squared. So T is going to turn out to be 71 divided by 4.9. And then I'm going to square root that. And I get 3.81 seconds. 3.81 seconds. So now we have the time up and we have the time down. And if we add those together on a good day, they should match the answer, 1.13. We get 5.24. All right, that's looking sweet. All right, and now we want to know the final velocity. With what speed does it hit the ground? So I think we could use the final velocity is the initial velocity plus AT. So the final velocity is going to be 9.8. And the time that I have to put in is just the falling down time, because that's when it's picking up speed. So that would be the 3.81. So 3.81 times 9.8. And I get a velocity of 37.34. 37.34 meters per second. I just want to point out that I have seen this question multiple times on the IB physics exam. They like dropping something out of something, a helicopter, hot air balloon, or whatever that's going up, so that we get used to the object will continue to go up before it falls down. And the more times you see a problem like this, the more times you're apt to remember that. All right, I'll end this video and start a new one.